Okay, we're going to do a quick video about the mean and median of the data set so that we feel confident to answer questions on take-home quiz number 2. This is my fault entirely for covering this a little bit too early in class in chapter 2. I got excited when we start talking about histograms and stem and leaf plots. I just want to describe them and talk about their centers, but we're not there yet in this new book until chapter 3. So first, let's define the mean. Another word for the mean is the average. And that would also be like the sum of all the values divided by the number of values. And we also want to define the median in our data set, and that is the value that splits the bottom 50% from the top 50% of the data. So we literally list our data from least to greatest, and you count in from either end of the list. So you move from the minimum value towards the middle, and then you move from the top value towards the middle. And when you meet in the middle, that's where you find the median. I'm assuming that that's something that you might remember doing back in maybe middle school, is finding the median by hand, maybe in high school too, actually. Okay, so thinking about these two data values, now I want to talk about when we would use either of them in terms of an appropriate center. So the actual question I really wanted to answer with this video is choosing an appropriate center. So what we want to think about when we're asking this question is actually what does the picture, the histogram, or the stem and leaf display, what does it actually look like in terms of its symmetry? So we're going to base this is based on symmetry. So we have two options actually. We either do have a symmetric picture, right? So it's symmetric, meaning if I fold it down the middle, it looks the same on either side. If our data looks symmetric, then we would always use the mean as the appropriate center. And just to be clear, I want to draw you a little picture. That would be that's a little wonky, but that's some symmetric data. And the mean will actually lie in the middle of that picture. It'll lie smack in the middle. And just to be clear, so will the median. But because the mean is an average of values, we actually use addition to find the mean. Those two are a pair, the mean with symmetric data, because there is an equal number of low data as there is high data. So finding the mean actually will result in finding the number smack in the middle if it's perfectly symmetric. We'll learn a little bit more about why the mean is so important in, I think, section 3.3 for symmetric data. Okay, second would be if your data is not symmetric. So that means you have data that's skewed either left or right. And in this case, if my data is skewed left or right, then I would actually choose, I'm going to draw an arrow because I want to draw two pictures on the right. I would actually choose the median as the appropriate center. And I would like to show you why with a little illustration on the right-hand side here. So if I have data that's skewed to the left, that might look something like this, where the majority of data is on the right-hand side, but there's a longer tail on the left-hand side. So this data is skewed left. And if we're thinking about the two centers, the mean or the median, the mean is also called X bar in our calculator. I just realized I forgot to say that earlier in the video. I genuinely apologize, but I want to use that notation here in this picture as well. So in data that's skewed to the left, when we're talking about the mean, it's a sum of all the values. So when we add values that are extremely low and and only a few of them to a lot of values that are incredibly high, it actually pulls our mean lower towards the skew. So your mean ends up, this is going to be a little drastic, but our mean ends up towards the left-hand side or in the direction of the skew, and our median stays where the majority of our data is. And that is why we would select the median as the appropriate measure of center if the data is skewed. Let's try this with a picture that's skewed to the right as well, just so that we're clear on what's happening. Oops, that's not a straight line. Let's try again. Okay, we want to make sure this data looks like it's skewed to the right, so that means that there's more data on the left than there is on the right-hand side. So this is skewed right. And really what I want you to think about is the comment we made about the mean. We said the mean is going to be impacted by these very few extreme values. So if the majority of us are sitting in the lower end of the data or on the left-hand side in this picture that's skewed right, then the mean is actually going to be pulled towards the right-hand side by the extreme values lying on the right-hand side. And again, I'm being super dramatic with how far to the right I'm drawing the mean, but I think this will help make the distinction clear. And again, the median is going to remain where the majority of our data lies, because it's the halfway point in terms of 50-50. And when the data isn't symmetric, the halfway point lies more towards that big bump of data where the majority of the data exists. So I'd like to write a reason why underneath choosing the median. And so I'm going to say that the mean is pulled in the same direction as the skew. And that is why when the data is skewed, we would choose the median as opposed to the mean as the most appropriate center, because it will not be impacted by the skew. The mean is impacted by the skew. Okay, hopefully this helps you feel more confident about take-home quiz number 2. And I will make sure that everybody has access to this video as soon as possible.